Hello and welcome back. So, some of you have already told me that you know what heat is, what gives heat. Some of you have said that the sun provides heat, that we need heat to survive. You've told me when you're cold, you put on a jumper to warm yourself up. Or you might have told me that if you have too much heat, you get burned. So to begin our unit, we want to look at how heat moves. But to understand how heat moves, you need to understand exactly what heat is. If you haven't already, I want you to have a look at the first activity, so not your KWI chart, but your first activity in your book. You put your hand on your cheek. What does it feel like? My hand's warm, but my fingertips are always really cold. What about the ice cube? Did you put the ice cube on your cheek? You probably didn't really need to put the ice cube on your cheek to be able to tell me it was cold. How many of you did though? What about when you put the ice cube on your hand? What happened? The ice cube started to melt. Now you can all probably tell me that the reason why the ice cube on your hand started to melt was because your hand is warmer and it melts the ice. But what's the actual science behind this? How does that heat transfer from your hand through the ice cube to make it melt? Heat is actually an energy, and temperature is how we measure that energy. We often say that everything is made up of molecules, but it's not entirely true. All matter is made up of molecules, and matter is anything we can touch. So the seat that you're sitting on right now is matter. It's made up of molecules. Water is matter. It's made up of molecules. I'm matter and made up of molecules. You are matter and made up of molecules. Cars, books, even the air is made up of molecules. They're made out of matter, therefore they are molecules. But something like sound isn't something you can touch, so it's not made up of molecules. I was asked last year about molecules and atoms. Now this is not something that you really need to know, but if the question comes to your mind, what about atoms? Atoms are actually part of what molecules are made up of. So you've got molecules, and that's sort of what we're going to talk about this term, but our molecules are made up of things like atoms and electrons. But for this unit, all you need to know is that matter, anything we can touch, is made up of molecules. So these molecules aren't just sitting still. They are constantly moving. They are vibrating, or they're moving back and forth and bumping into each other. Just how much they move, it depends on how much heat energy is in that matter. So what temperature it is. For example, our ice cube doesn't have a lot of heat energy. It's a cold temperature. Therefore, the molecules don't move a lot. A bit like Mrs. Beard on a cold winter's morning. The molecules stay close together and they just move a little bit. If the matter is hot, the molecules move quickly, they are vibrating, they're bumping into each other, and there's a lot of space between each of the molecules as they're moving around. This picture might help illustrate this for you. Another way I can illustrate it for you is a tray with marbles in it. Okay, so when it is cold, when matter is cold, so remember that's anything we can touch, these things are all made of matter. So when matter is cold, the molecules only move a little bit. They stick together, a little bit of vibration, but they don't move a lot. As it warms up, they start moving faster and they start
colliding into each other, bouncing off one another. You'll notice there's a big space between them, creating more heat energy, therefore a higher temperature.
So what actually happens when we put the ice cube on our hand? So the molecules our hand is made up of have a lot more heat energy in them than the ice cube does. They're moving faster than the ice cube's molecules, and there's more space between them. When we place the ice cube on our hand, the molecules from our hand bump into the molecules that the ice cube is made out of, making them start to go faster and transferring their heat energy from our hand to the ice cube, which warms up the ice cube and makes it start to melt. In the process, the molecules in our hand start to slow down because they have lost some heat energy when they've bumped into or collided with the molecules from the ice cube. And so our hand starts to cool down. And then in the end, once your ice cube's melted, it's actually quite cold. But it doesn't stay cold, does it? Our hand will eventually warm back up again as the molecules from the rest of our body bump into it and start warming it up again. There's a fly, it's really annoying me. So if we're going to draw a diagram, it would look a little bit like this. So your diagram could look a bit like this. Remember, a scientific diagram, it's a simple line drawing. I haven't included labels because I didn't want to give you all the answers that need to go on your sheet. But this is a way you can illustrate the way the molecules are moving. Hand, with my ice cube on my hand, you'll notice the molecules on my hand, or on the hand, have got quite a bit of space between them, and those little lines behind them to show that they're actually moving. The molecules in my ice cube, which is cold, have got minimal movement, a little bit of vibration, no lines behind them to show that they're zipping about, bumping into anyone, and they're all close together. So remember, when you're drawing a scientific diagram, we just use a simple line drawing and we label it. Have a go at drawing the second diagram on your sheet for me with the melted ice cube. It's important to note here that heat will always move from the warmest, so the heat energy will always move from the warmest thing to the colder one, and it's always trying to get equilibrium, so it wants everything to be at that same temperature to get those temperatures equal. Hope that made sense. Next video is a quick little demonstration, an experiment you can try at home to check out that molecule movement. See ya, bye.